the words gyro compass having two words, gyro and compass. Just to talk about the compass, you all know, compass is a device that gives us direction on the surface of the earth. When the ship is navigating, it is going in this direction or this direction, तो मैं अपने चारों तरफ देख सकता हूं, that is in circle. So where I am right now looking at must be measured, so that measurement has to have a 0 point. If I say height, I take it from sea level. तो ये 0 है और यहां से ऊपर है या इससे नीचे. If I talk brightness, then I need to have a 0 brightness and then 1, 2, 3 brightness की बात करनी. If I want to talk about length, then there has to be a 0 length and then measurement has to be there. When we talk latitude, longitude, there has to be a 0 point. Equator 0 point, either 90, either 90. Longitude, Greenwich meridian, right now we are talking, but you must also know that before they started the Eurocentric ho gaya sara, before it started from there, we already had the prime meridian passing through Ujjain. And our time calculations and everything was way back available with us. So many people have taken things from here. They have taken the knowledge from India and then branded their own और सारी दुनिया को बताते. Just talking about this, Newton's law of motion was already in our scriptures, and one of the universities have acknowledged that Newton stole the laws of motion from us. Acknowledged, at least as the websites are saying. Similarly, they said somebody found gravity there. No. Gurutva was already in use in India. We always knew it as Gurutvakarsan. It is mentioned in the scriptures. They said earth is flat. Later on, some few hundred years ago, they said no, it's round. No, we used the Bhugol way back. The earth is goal. It is spherical, round. Anyway, so direction also has to have a reference point from where measurements can be done. The circle is divided in 360 parts, you know, each one is called a degree. But there is also another measurement of the circle, what we call radians. Radian is also a measure of angle. Degree is also a measure of angle. However, just for idea, one radian is 57.3 degrees. 57.3 degrees is one radian of angle. But we don't use radians for direction finding because that is too big a unit. We need smaller units. So 1 degree, 2 degree, 3 degree, 4 degree, 5 degree, like that. So in our case, the 0 point or the reference point for measurement of direction is the longitude. The meridian, which is running line, imaginary line running from north to south. So we take the reference from the north end or north se measure karte. So that true north is the reference 0 degrees. All directions will be measured from 0 degree. Of course, you all know about it, 100% you know. But since we are talking about we need to just talk about it. So a device that gives us the 0 reference point north is a compass. The compass will always point in that direction, that this is the 0 degree. Now if the ship is going here, it is going on 0 degree. If proceeds like this, it will reach North Pole. But if she is going here, this is the number of degrees that we are talking about. So this is, let us say 30 degrees or 40 degrees or 90 degrees or 180 degrees, that you all know. So compass is a device which is supposed to be pointing to true north. And we can measure our situation, let us say forward aft line of the ship. If it is matching with the compass, then the ship is going on 0 degree. If the forward aft line is at an inclined at an angle to that device 0 degree, that's the angle or the course that the ship is doing. So that's compass. The other word that we are using is gyro. Gyro or something called gyroscope is at the heart of this compass. The device function is to show the true north, but how we are making use of it or how we are getting this kind of result is using something called gyroscope. So first 3, 4, 5 classes we will not be talking about compass. We will only be talking about gyroscope. Then we will start converting this gyroscope into a compass, a device that can point to true north all the time. No matter where you are, it should point to true north. So what is a gyroscope? Gyroscope is nothing but a wheel, sometimes known as a rotor, which is suspended about a axis. मतलब एक व्हील है जो घूम सकती है एक एक्सिस पे. Like your cycle, bicycle, उसमें चक्का है, तो चक्का is basically a disc or a ring or rotor or wheel, and the axle is around which it is rotating. So that wheel can be termed as a gyroscope. Of course, the major function is not gyroscope, but गाड़ी चलाना है उसके लिए. So the application of this gyroscope is for travel, or maybe a fan. It is hanging by an axis and the rotor is rotating. रोटर के साथ हमने ब्लेड लगा दिया, हवा मिलती है. So this gyroscope can be used on, and it is being used in thousands and thousands ways, having different purposes, serving different purposes. But here we are going to make use of this gyroscope for making a compass. So what we said was a gyroscope. We have made some props for you, sorry, so that it is easier to understand. So here is kind of a gyroscope, a wheel which can rotate about an axis. So this is wheel and it is well balanced. ऐसा नहीं कि एक तरफ ज्यादा एक तरफ कम हो, तब वैसे motion will not be correct. So a wheel suspended on the axis. This is what a, yes, somebody saying something.
Yes, sir. The Explorer is there. I just received the from.
आपकी आवाज सही से नहीं आ रही है, थोड़ा माइक्रोफोन नजदीक करेंगे और बैकग्राउंड नॉइज भी थोड़ा सा आ रहा है. Difficult to understand. Please go ahead.
As I'm saying, I'm just received this link from admin, sir. For phase 2 September batch.
Okay, September batch, Gyro. Okay. So we have just had introduction and we are starting a new topic of gyro compass. We are just beginning the gyro compass. So welcome you to
Okay, sir.
and in my class. So we have just started. We were talking about the compass is a device that gives us the direction. The zero direction, just say with reference to which we are able to measure the direction. So there has to be a reference 0 point, and with respect to that 0 point, we measure the direction. So this compass, the gyro compass, is going to use a gyroscope, which will be like this. What is a gyroscope? Basically a rotor, a wheel, which is suspended on a axis, what we call the spin axis. This rotor is spinning about this axis. This axis is perpendicular to the plane of the rotor. This is the plane of the rotor. The axis is perpendicular to the plane of the rotor. We will see the properties associated with gyroscope. But this gyroscope by itself cannot be used as a compass. जस्ट ऐसे कर दिया तो ये घूमेगा तो कहीं तो टांगना पड़ेगा तब तो घूमेगा. So we need to have some kind of arrangement to make it suspended like this where it can rotate. But remember that it is supposed to be always pointing here. If it is kept on the ship is going there, it should always point to the north. So this is the spin axis, which is the pointer. This pointer itself always points to north. So that will be coming in more detail later on. But right now, what we have is that this gyroscope must be converted into something called free gyroscope. So this gyroscope is not free because I'm holding it with my hand. So it is always going to be in this direction because I'm holding it like this. It is not free to turn like this or like this or like this or like this. It is not free. Because the compass will be always in that direction irrespective of where I am going. It must be free to rotate. नहीं तो जहाज पे अगर फिक्स्ड होगा तो जहाज के साथ घूम जाएगा. तो जहाज पे होने के बावजूद it should be free from the motions of the ship. When the ship is going like this, it should be free. When the ship is going here or here, it should be free. So we need to make this gyroscope a free gyroscope. So what is a free gyroscope? Again, we will start with the same wheel and a spin axis which is perpendicular to the plane of the rotor. So we start at this only. ये तो होना ही है, gyroscope है, इसको free करना है. So this particular thing is placed inside a system of rings. इसको हम एक रिंग के भीतर में डाल दें like this. तो यहां इस रिंग के भीतर में ये घूम सकता है. Then we have other rings also, and those rings are called gimbals. So this rotor and the spin axis is suspended between a system of rings called gimbals in such a way that it can move in any direction. ऐसे घूम सकता है, ऐसे घूम सकता है और ऐसे तो घूम ही सकता है. So how they are placed, this system of rings called the gimbals are connected to each other at 90 degrees somewhere, somehow, so that it provides freedom to this rotor. The rotor can move like this. So it can move in this direction along this axis, or it can move in this direction, horizontal plane, about a vertical axis. And of course, it can rotate about the spin axis itself. So how is this free gyroscope constructed? What are these rings? What do they look like? How they are connected with each other so that it is providing the gyroscope freedom of movement in all directions. So I made a prop for you, which is like this. This is a free gyroscope. Remember that at the center there is that same rotor, and there is this spin axis. The spin axis and the rotor is suspended within the first ring called inner gimbal. This is the inner gimbal. So this is placed in this orientation, and at 90 degree here it is suspended within outer ring, the outer gimbal, so that it can rotate about this. So एक pivot यहाँ पे और pivot यहाँ पे है, so it can rotate about a horizontal axis. Is that horizontal axis or not? Yes.
Yes, sir.
So this is horizontal axis, and of course the rotor can rotate about the spin axis itself. So it can rotate like this about the spin axis, and then the whole of the rotor can also rotate about a horizontal axis. रिमेंबर कि ये बीच वाली घूम रही है, ये रोटर घूम रहा है और घूमते हुए ये यूं भी घूम सकता है. But then this outer ring is also placed here on a base, the base called a phantom. This is the phantom on which this ring also can rotate. This can also rotate like this. So is this rotation, the rotor, is it rotating about a vertical axis?
Yes, sir.
So now the rotor can rotate in three orientations. एक तो spin axis पे. The rotor can also rotate about a horizontal axis, and the rotor can also rotate about a vertical axis. So it has got 3 degrees of freedom. 3 degrees of freedom: freedom to rotate about the spin axis, freedom to rotate about a horizontal axis, and freedom to rotate about a vertical axis. And so it is free gyroscope. अब मान लीजिए इसको हमने शिप पे रख दिया. अगर शिप रोल कर रही है तो is the rotor free from the rolling motion of the ship? अगर शिप इधर उधर हो रहा है तो is it free from that?
Yes, sir.
If the ship is going port starboard, is it free? The rotor is free from this movement or not?
Yes, sir.
Yes, sir.
So it's a free gyroscope. So free gyroscope is consisting of the rotor, the spin axis, the inner gimbal, the outer gimbal, and the phantom, and they are arranged in such a manner that the rotor has got 3 degrees of freedom: freedom to rotate about spin axis, freedom to rotate about a horizontal axis, also called torque axis. This is called torque axis. We will see, we will understand why it is called a torque axis. Then there is also this vertical axis about which it can rotate. The vertical axis, also known as precession, a precession axis. We'll also understand why precession axis, what is this torque, and what is this precession. We'll come to that. But before we proceed from here, we need to understand little bit about rotary motion or circular motion. When I apply a force on an object, the object moves in the direction of the force. अगर इधर से लगाता हूं तो इधर जाती है, इधर से लगाता हूं इधर जाती है, नीचे से करूं तो ऊपर जाती है, ऊपर से लगाऊं नीचे जाती है. It moves in the same direction, an object. But if an object is suspended free to rotate about an axis, and if I apply the torque or force, again the whole thing will move. For example, if I apply a force here at the axis itself, the whole thing is rotating. But, or if I, not rotating, but moving. If I apply a torque like this, directly towards the center of it, then it is moving in the same direction. But if I apply that torque at right angle to it, then it rotates because it is suspended about a vertical axis. और मैं इस axis से दूर में force लगाता हूं तो it is moving. If I apply here itself, right in the center, here, इसके भीतर में लगाऊं, so this gets pushed towards you because I am pushing the force in your direction. But if I apply this at an angle away, at a distance away, then it rotates because it is free to rotate about a vertical axis. So we'll go on the board to discuss this. All right. So we have seen that there is an object. If I apply a torque at the center of gravity directly, then the whole thing moves in the same direction. But if it is suspended here and I don't apply the force here, I apply the force at a distance away. At D, I apply a force. Then this will be rotated about this axis. So a force can produce a turning motion when applied not at the center but at a distance away from it. In our case, the object that we have is a rotor. The rotor is suspended about the spin axis. If I apply a torque right at the center here or force at the center, this does not produce any turning motion. It will be pushed in the same direction, the whole thing. But apply the force at a distance away from the center at 90 degree. At 90 degree, then this makes the wheel rotate about this axis. How much of turning force? As can be seen that when the force was applied, the turning was 0. As we are going away from the distance, from the center, this turning force is increasing. For example, अगर आप दरवाजे को चौखट पे है और यहाँ पे फोर्स लगाते हैं हिंज पे, तो बहुत मुश्किल होती है, और यहाँ पे लगाते हैं तो दरवाजा आराम से खुल जाता है. So we are applying again a torque here. जो हम दरवाजे को पुश करते हैं, force we are applying. If we are applying at a distance away from the hinge, then the door opens easy. I require less force to turn it. But if I apply the force at a distance very close, this will not turn easy. I need to increase the force because the distance D has reduced. Distance more, F small. Distance less, force very high. That means this turning force is a product of this D and F. This turning force is called moment, which is given by F into D. But we are of course applying at a distance D here. If I apply the force at 0 degree directly to this, again it is becoming in the center. Only maximum is obtained, maximum turning is obtained when it is applied at 90 degree. That means into sin theta, where theta is the angle of application. जैसे जैसे हम फोर्स का डायरेक्शन चेंज करते हैं, 90 से 70 किया, 60 किया, 40 किया, 30 किया, जैसे जैसे हम इधर की तरफ बढ़ रहे हैं वैसे वैसे टर्निंग फोर्स कम हो रहा है. जब 0 डिग्री पे आ गया तो टर्निंग फोर्स खत्म. So the moment is F into D into sin theta, where F is the force, D is the distance at which the force is being applied, and the theta is angle of application force. Very popularly, we know this as torque. So what is torque? It is basically turning force. When applied on an object which is suspended about an axis, when a force is applied at a distance of D away from the axis, it will produce turning of that object about the axis. So this you have very often seen in case of vehicle specification, this much of torque, this much of power. So power and torque are two major specifications when you are buying a vehicle. Why? Because the engine is producing turning of the wheel. So how much of turning torque, how much is power, that is what we are talking about. We are not interested in power, but in torque. So torque is simply a turning force. Now when you apply this torque, it starts to rotate. How fast it is rotating? How fast will it rotate? Of course, it may be moving slowly, it may be moving faster. So we need to find out how fast. So the rotation has to be measured. And how do we measure? By something called angular velocity. Omega. So can somebody define for me what is angular velocity? Somebody help me. How do we define angular velocity? Of course, linear velocity, if I was at A and if I'm going at B, the time taken to do this distance divided by time will be the velocity. But I'm going from A to B. This is linear motion, linear velocity, displacement by time. But what will be this angular velocity? Angular velocity, देखो भाई, अगर नहीं आता तो बोलो कि आगे बढ़िए, यू से, तो मैं चालू हो जाऊंगा, लेकिन कुछ नहीं बोलोगे तो फिर दिक्कत होगी. आई आस्क्ड ए क्वेश्चन.
नहीं आता सर.
हाँ, तो ऐसा बोल दो, कोई इशू नहीं, कोई इशू नहीं है. वी मस्ट कम्युनिकेट. हियर वी आर फॉर लर्निंग, not that I just want to find out. If you know, it's all right. Then I'll take help from you also. So angular velocity is the angle covered in unit time by a radius. The sweep that it is doing in unit time, let us say 1 second. How much of angle covered by the radius? So angle per second is basically the angular velocity. So what we can say? Okay, 35 degrees per second we can say. Or if it is turning a little fast, we can say 720 degrees per second. But degrees are becoming bigger and bigger. So we can say, let us say another unit, 50 radians per second. So this is a unit, degrees per second, of the angular velocity. Radians per second, again angular velocity. But most popular of all these units for angular velocity, this you should know. सबसे ज्यादा इस रोटेशन को हम किस में मेजर करते हैं?
आरपीएम में.
That is right. RPM, revolutions per minute. Because these numbers will become too big when something is rotating very fast. So we use revolutions per minute. So that's angular velocity. Now suppose this was moving, already rotating at certain speed. And if you want to stop it, आपके छूते ही क्या ये रुक जाएगा, ठक से करके रुक जाएगा, या रेजिस्ट करेगा आपके रोकने को? If somebody was saying something,
अगेंस्ट में फोर्स लगाना पड़ेगा तब रुकेगा सर धीरे धीरे.
that means this will not try to stop, it will try to oppose your force. If the vehicle is going like this, if you are standing here and trying to push it back and it was coming, definitely you will be pushed here, because it is already moving in your direction, and the tendency that it will continue to do the same thing. It will continue to do, go ahead. If you try to stop, you have to apply some force in opposite direction. When the force by this and by this is equal and opposite, then only this vehicle will stop. Similarly, if you are opposing this, then this will continue to rotate. अगर कोई opposing force नहीं हो, तो this will continue like that forever. If I rotate this, it is rotating continuously, but slowly it is reducing in speed. धीरे 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 कम हो रहा है. क्यों कम हो रहा है? Because there is a
because
friction.
of the air friction.
Air friction, also the bearing is the more the prominent friction here. बट चूंकि बॉल बेयरिंग है तो फिर भी होल्ड कर रहा है, थोड़ा अभी तक चल रहा है. So why is it rotating continuously? Once rotated, why is it rotating?
Because of the inertia, sir.
Angular momentum की वजह से.
Very good. Inertia. Inertia. So inertia makes something do what it is doing and remain in that same state. Inertia says that an object will be in the same state of rest or motion until and unless an external force is applied. तो जो पत्थर आपने रखा हुआ है बाहर में देखते हैं आप, वो हर सुबह वहीं पे पड़ी मिलती है, लेकिन एक दिन थोड़ा हिला हुआ मिला. क्यों? क्योंकि गाड़ी ने आकर के उसको थोड़ा सा धक्का मार दिया तो उधर साइड में हो गया. So inertia makes that stone piece remain there itself all the time. When the vehicle is moving, आपने एक्सीलेटर दिया, 60 पे पहुंचा दिया गाड़ी, और न्यूट्रल करके पेडल पर से हटा लिया पैर, फिर भी गाड़ी चलती रहती है. ऑफ कोर्स धीरे धीरे कम होती है, रेजिस्टेंस हो रहा है, ग्राउंड फ्रिक्शन है, एयर फ्रिक्शन है, so that is slowing it down. But then it was having this tendency to continue on in the same state. अगर फ्रिक्शन जीरो होता तो it would continue to do the same motion indefinitely. Also, this one is rotating, but there is bearing friction, there is air friction. Because of this, it is stopping. So when it is rotating, I have to stop it. How much force is required? How much force should be required to stop this wheel? Of course, अगर धीरे धीरे घूम रहा हो, हल्के हल्के घूम रहा हो, तो force required, and when it is turning very fast, then the force required, will it be same or different?
Different.
Different. So that relates to the angular velocity. How much inertia it has depends on this. All right, very good. Now suppose the mass, you have the wheel which is of cycle and of truck. एक ट्रक टायर है, एक साइकिल का टायर है, दोनों एक ही आरपीएम पे घूम रहे हैं. मान लीजिए दोनों एक सेकंड में 20 चक्कर घूम रहे हैं. तो the force required for this and this, will it be same or different? Different. In which one you will require more force?
टायर में, ट्रक के टायर.
ट्रक के टायर में. तो इसकी inertia was one depending on the angular velocity and the other factor that was the mass. So हल्की चीज है, जितने स्पीड पे घूम रही है हल्की चीज है, तो इसको अपोज करना आसान होगा. इसका इनर्शिया कम है और इसकी इनर्शिया ज्यादा है. So how we can relate this and this together so that we are able to quantify the inertia. To measure the inertia, we use the term angular momentum. Like the velocity, linear velocity के साथ हमारा angular velocity हो गया. Momentum जो linear momentum होती है, which is mv, mass into velocity. Now here it is angular momentum, where also we are seeing that mass and velocity are involved. So now I have few challenge for you. for identification. Challenge मतलब पंजा लड़ाने का ये नहीं है. So here are three conditions. We have seen that the momentum or inertia is depending on mass and angular velocity. So I have a rotor which is made like this. It is on axis. It is having a mass and of course it is having a radius. बड़ा भी उतना ही है. Then I have another one. थोड़ा सा कंस्ट्रक्शन उसका चेंज कर दिया हमने. The same mass, but from here I have pulled the material and put it outside. Radius is still the same. This is case number 2. Number 3, I have made another design. This also the radius is same, the mass also is same, and they are all rotating at the same angular velocity, omega. All masses same, all angular velocity same, the dimensions also same, the radius also same. Now, if you want to stop it and stop it. सबको रोकना है आपको. The force required in each case, will it be same or different? That was the challenge that I was talking about. Will the force be same? Go ahead.
Different, sir.
Different. What is the reason for different being different?
So comparing one and second में जो अंदर का मास कम है, बाहर में ज्यादा है, तो इसलिए ज्यादा फोर्स लगेगी.
Okay, very good. So you are requiring that this will require maximum force to stop. That means angular momentum is more here, inertia is more, right? इसका inertia ज्यादा है तो उसको हटाने के लिए, उसको चेंज करने के लिए I need more force. जैसे छोटा पत्थर कम inertia, आराम से मैं हिला देता हूं उसको. बड़ा बोल्डर वो नहीं हिलती, उसका मास ज्यादा है, ज्यादा inertia है, it requires more force to move. तो जैसे भी बुलाना पड़ता है. So in this case, we are seeing that the mass is same. Very rightly you said, here on one side if you see, the mass is concentrated at the center here. On one side, अगर radius center से देखें. In this case, the mass is concentrated somewhere here from the same radius, from the center. In this case, the maximum mass is concentrated here. So the effective radius in these three cases we are saying is this and this and this. And on the basis of this, this requires maximum force to stop. That means it has got maximum inertia. That means not only the mass, but the mass distribution also makes the difference. Each particle here has got a mass. Each particle has got a mass, and each particle has got its radius. ये वाली और ये वाली और ये वाली सब अलग अलग. हर पार्टिकल का अपना एक मोमेंटम बनेगा. मास into radius, mass, radius, plus of course the angular velocity. When we integrate all this, we find that there is an effective radius. So now the inertia And because of inertia, the angular momentum H depends on number 1, number 2 and number 3. तीन चीजों पर डिपेंड करता है. Not only the mass but mass distribution as well. So inertia, when it is rotating, we will call this gyroscopic inertia. Because it is rotating, gyroscope is rotating, so that gyroscope will have a gyroscopic inertia. जैसे घूम रहा है तो घूमता ही जा रहा है. It is because of inertia, because of its angular momentum. So the inertia with which it is moving has to be measured, and that we measure it by something called angular momentum. H. And as we have already seen that this angular momentum H is depending on three factors. H is equal to I omega. अब ये I कहां से आ गया? Where I is called moments of inertia. And given by mr square by 2. This is the overall mass. This is the mean radius. जो हमने तीन radius देखे थे, उसका mean radius square by 2. So I is equal to mr square by 2. Of course, I में mass भी है और mass distribution भी है. Of course, omega is the angular velocity, RPM. It is because of this that something is rotating, it will continue to rotate if no friction. Earth and all the planets and the moons of different planets, the solar system, the galaxies, they are going round and round and round and round. Earth पता नहीं कितने दिनों से घूम रहा है, because it is not having any kind of friction, so it is continuing to rotate. But the rotation of the Earth and maybe Mars was not the same earlier. It was something else. जब कुछ collision हुई तो उसका axis भी है, वो भी तिरछा हो गया. तो अर्थ तो हमारा 23 degrees पे रोटेट करता है. There is a planet which is rotating like this. अर्थ के चारों तरफ घूमता है, but it is horizontal axis पे घूमता रहता है. I think Mars. So this is about circular motion. Are we clear about the gyroscope and little bit of angular